Hi, this is the panel for making ARM devices just work. I'm Doorn, a fellow at Harb. I'm going to be the moderator today, and I'm very happy to have invited the following people to join as the panelists today. Leendert van Doorn, distinguished engineer from Microsoft. John Masters, well, when I invited John, he was with Nuvia as the VP of Software Engineering. Now he's returning back as a distinguished engineer at Red Hat. That's why you see two Red Hat people joining us. The next one is Peter Robinson, Principal IoT Architect at Red Hat. Andrei Warkentin, the ARM Enablement Architect from VMware. Last not the least, Harb Abdulhamid, Senior Distinguished Engineer from Ampere. Thank you all. So today what we are going to do is to talk about this new ARM System Ready program that I just introduced earlier today. The key vision of this program is to make software just work on ARM devices. It is a foundational compliance certification program that we do for and with the ecosystem that builds on the existing Server Ready program that we launched a couple of years back. We do this together with the ecosystem that will set the standards for a broader set of devices, initially for the server infrastructure, edge, and IoT. Our vision is that the software that works seamlessly across a vibrant, diverse ecosystem of hardware. We focus on the common components of the software stack for the operating system, for the hypervisors and middleware, to make these just work, enable the partners to focusing on the differentiation for innovations and deploying the solutions at the application layer. The focus is to establish a uniform hardware system architecture, as well as the consistency around key processes like boot. We use the standards approach. This way we can lead to faster and simplified solutions to market for our partners. It is also a foundation of Project Cassini that we're introducing the content as well at this conference, which is alongside with the PSA security and cloud native experience at the edge. So in this program, we have one program with multiple bands. So for servers, we continue the Server Ready program with the requirements on the BSA and SBSA supplement for hardware. And then we continue this solution that is basically based on the original SBBR specification, which is now a new recipe. For servers, for some of the hyperscalers, they would like to see Linux boot being used. So we also introduced a band for System Ready LS. It is the same hardware requirements, but for firmware, we anticipate that some these systems will be using Linux boot. And then on the edge and IoT space, we basically use a reduced version of the hardware spec, basically the BSA as the foundation. We don't require the server-specific supplement. And then on the firmware side, depending on which OSs you want to use, if you want to use the OSs like Windows IoT Enterprise, VMware, Red Hat, then you would want to continue to use the SBVR firmware. But if you want to support some of the other OSs that only supports, that need only the UEFI support, you can do with the System Ready IR. And this is the EBVR requirement that you're going to be complying to. And then we have a couple of options related to addressing the silicon issues, especially with PCIe in the pre-silicon space. And then we also offer an additional option on security to support UEFI secure boot and firmware updates. So with that, we have these bands, beautiful colored stamps that people will be getting when the systems are certified. And we actually have quite a few sessions, including keynotes and different technical sessions in this DevSummit that you can check out. A lot of them are related to system ready. So next, I'm going to be asking questions to these panelists. And the first one is, what are the benefits of extending the standards approach to the infrastructure edge and IoT space? And I'm going to start with Andrei.
Hi. Well, the primary benefit is creating a horizontally integrated ecosystem with the same level of mutual OS and solution compatibility as the competitor space, avoiding vendor lock-in and making customers less wary of adopting ARM-based technologies with IoT and edge solutions, keeping deployment and maintenance costs under control. To be fair, some of the infra edge stuff is approaching microservices already, so the standards just formalize that.
Leendert?
Yeah, thanks. So similar to that, I mean, to me, standards are about preserving your investment, right? The investment that you make in drivers, in tooling, in operating systems. And those are obviously important to Microsoft because we do play in the IoT space, we play in the edge space, right? We obviously play in the server and client space. So seeing a common base where we can use our one core OS, so our base OS that's being used for Windows on all these different platforms and reuse that investment is extremely critical to us. We've been fairly successful with that in the server ready space. So there now the same Windows version can boot on an Ampere system, it can boot on a Fujitsu system, it can boot on a Marvell system. And we obviously like to see that those same benefits in the IoT and in the edge space as well.
Peter.
Yeah, speaking with customers, I'm hearing very similar things to what the other two people have explained. Our customers want the ability to deploy the same systems they have in the data center, but pushed out further to the edge. Have the ability to do things in a very similar way, sysadmins with the same experience, without having to run different versions of Linux and different platforms than they do on the edge as in the data center. They want simplicity, they want the same. They want to be able to reuse a lot of their infrastructure that they're using in the data center out on the edge as well. Reuse the knowledge of their teams to expand out there without having to employ or retrain teams to do things in different ways. They just want things to just work.
Great. So in the new System Ready program, which bands are important to you and why? So I'm going to start from John.
Could you repeat the question?
Oh, the question is, in the new System Ready program, I talked about the bands, right? Which bands are important to you and why?
Well, I think it depends on the use cases that you're looking at. So if you're looking at server, which has been my traditional focus, then I think the SBSA and SBBR specifications are the key enablers. If you're looking in the different edge cases, I'll pile on to what Peter has said just now. To me, everything is a server. They're just bigger and smaller servers. So from my point of view, a lot of the existing server standards apply in all of these emerging areas as well.
Peter, do you want to add anything?
Yeah, from an edge perspective, ultimately, wherever possible, we'd like server ready. The ES standard is certainly very useful, and I think it covers a lot of use cases that we have customers that are interested in, and will help resolve a lot of problems in the space, especially in the lower end devices. My role covers both the enterprise product, but we also have a community product in Fedora IoT, and we actually have a lot of companies that are looking at and deploying Fedora IoT in the edge and IoT space as well. And certainly in the community space, the IR is interesting and useful because it helps standardize. And the more standardization and the more similarity across the ecosystem is extremely important there as well. But from the enterprise point of view, certainly server ready, and to a slightly lesser degree, ES is my focus.
Andrei?
Sure. So VMware is interested in open and horizontally integrated ecosystem solutions, ICE agnostic where possible, and so driven by mutually compatible industry standards, which would include hardware and firmware. We are a big believer into SR and ES bands. SR server ready covering, of course, the more traditional use cases, and ES covering edge compute. And honestly, expecting even more convergence in the future as this sort of high-end embedded hardware starts becoming more and more standardized.
Leendert.
Yeah, so Microsoft is really interested in all these standards. Right? We obviously have been working a lot with this whole community and others on server ready for the last, 6-7 years. But things like embedded server, right, clearly is embedded server ready. The whole edge scenarios, that's important to us. IoT is very important. I'm particularly pleased to see also a set of pre-silicon programs in there, because the earlier we can help our silicon designers to build the right silicon and not make mistakes, right, then we don't have to deal with it on the software end. So more focus on that front end of the whole process is, I think, a good thing for the overall ARM ecosystem.
Harb.
Yeah, so I'm going to be echoing a lot of the folks here. Our immediate focus is SR. I mean, I see it as a superset of a lot of these other ones. We're obviously looking at the others as well. We have interest in the others and want to make sure that we build silicon that is suitable for a broad range of systems. But again, SR is our immediate focus. I think, as mentioned during this conference, Ultra, with specifically the Ampere reference platform, which we call Mount Jade, has already been SR 2.0 certified, I believe. And we do care a lot about SBDR. From a silicon vendor's perspective, having these standards to guide not just us on how we should build our silicon, but also our OEMs, our customers, on how to build platforms and integrate everything together in a seamless or at least understandable way. And this is all of great benefit to us. So we try to participate as much as we can in as many of the server AC work groups and try to review and contribute all these different standards.
Great. I oftentimes get the question, like, the server market have a very strong market ecosystem pull, I think, thanks to you guys, right? And so the benefit of server ready program certainly. So that one, enterprise software binary can run on many different silicon. But there seems to be less of an apparent pull or the ecosystem benefit to the non-server market. What do you think about that? Can you elaborate as to what specific benefits this System Ready program brings to these other additional markets? Andrei?
Sure. So I think one of ARM's strengths is the flexibility and cost of building customized solutions at a platform or even silicon level. So this both means building the actual appliance or edge gateway, or if you're large enough, designing your own SoC for that. But when I hear customize, I also hear low volume. And so the only way to extract value from basically something that is heavily customized, both for customers and for the vendors involved, is to follow standards. If you can't have vendor customized operating systems, ad hoc ways of booting and flashing, especially when dealing with deployments that are at scale, that are in kind of a limited environments, think oil rigs, that sort of thing, that sort of environment. And the standards make it cheaper to deploy and support, and this also means the long-term support story, which is very important for IoT and Edge. You can't have everybody be stuck on a vendor-specific version of Ubuntu 16.04, for example.
Peter?
Sorry, can you repeat the question?
The question is about the ecosystem pool, whether or not we have a parent pool in the non-server space.
Sorry, I missed that.
If you want, I can chime in. And
yes, please, John.
Peter. Yeah, I would just sort of echo what we were saying before and what Peter was building on around Edge and other scenarios. I think the reality of life in server is the industry is well established getting software releases and having a backward and forward compatibility story. So I can get software updates in 10 years' time and I can run them on existing hardware. I think the reality of life is that what we've seen in a number of other markets is that in the past, there've been very bespoke, tailored, embedded systems, and that's a path to short-term revenue, of course, and it's a path to people getting products in the market and showcasing solutions. But what tends to happen is 5 or 10 years down the road, i.e., after the team that built it is long gone and doing several generations hence. That's when the customer really wants the value. They want to be able to get updates. They want to be able to do fresh installs. They want to get CVE fixes, all these kinds of things. And that is where these standards really bring value. And it's kind of the boring stuff. It's the pieces that, maybe don't look that appealing on the face of it. You're talking about some old hardware, but being able to support legacy platforms in the future is very, very important if we want to go into these emerging markets.
So to continue on what...
Yeah. Oh.
Sorry,
Peter.
Yeah, go ahead.
Yeah,
Peter,
just to continue on what John just said as well. A lot of vendors see like custom operating systems and proprietary platforms as a means of locking their customers in. But the other thing that they don't realize is that it also locks new customers out, because if they have to spend a lot of time migrating to a custom software platform, a custom operating system, training their sysadmins, it makes it really hard for not only people to migrate away from their platform, but to migrate to their platform. And ultimately, a lot of the vendors that ship, very customized versions of Ubuntu or Debian or CentOS or a bunch of other things, they have to support that. And customers are expecting, especially in the Edge and IoT space, industrial spaces and things like that, customers want 10 plus 20 plus years of support, and that's just very, very hard to do for a company where that's not their specialist sort of remit of dealing with operating systems and security responses and things like that. And so lock-in and non-standardization in this space just doesn't benefit anyone in the long term.
Good. Leendert?
Yeah, so there's been an interesting trend over the last few years. I think the ARM business model is one where there's no constraint about the IP and what you do. And so people tend to build all sorts of things, but we're slowly beginning to figure out that needless differentiation doesn't actually provide you with value. It actually costs you to support that. So if I look back at what Linaro did 10 years ago, where they brought sort of all these different Linux distributions together and said, okay, we'll maintain one core kernel for that. That was sort of the first step, but you still had lots of specific instances for specific platforms. And I think now folks are beginning to realize is like, you don't differentiate by having your own interrupt controller that is slightly different, or your own DMA controller that is slightly different, or having a DMA controller that cannot access all of memory, but only a certain part of memory. And so that's where this guidance, these standards are coming in are good. But as I said, standards are a way of preserving your investment. So it allows me to reuse whatever I develop for other platforms this particular case, server ready, and I can use it for edge, I can use it for IoT, I can use it for other things. So to me, that is one of the key trends, and I think people are finding out that needless differentiation doesn't really buy them anything.
Great. So the next question is interesting. So even though this is not really part of System Ready, but I've got a lot of feedback that ODMs really need to upstream kernel device drivers and some of the other kernel hardware enablement to Linux. Many of the smaller ARM ODMs struggle with this upstream code to Linux because they do not have reputation or standing in the Linux community. So what would you have the advices to them? I think this is more to John and Peter.
Peter, do you want to go first and I'll pile on?
Yeah. I mean, from Red Hat's point of view, it's very simple. If it's not upstream, we don't support it. It's the only way of viably long-term supporting things. Ultimately, Red Hat came with that policy after being somewhat burnt and having to deal with very, very long-term patch series that caused problems. And so from our point of view, it's a support nightmare, and it needs to be upstream to be supportable. And again, it's about lock-in or not lock-in. If like vendors think that not upstreaming stuff is going to lock people into their platform, you know, companies will find other ways of doing that. And I mean, you just need to look at the Android ecosystem, you know, for the huge problems there and the years and years it has taken to, you know, be able to boot those platforms on near upstream code. And it was only just this week that I read an article on LWN which outlined the fact that there's, I think, one major patch set to boot the main Android on upstream Linux. But you look at the years of effort to get there, you know, it's not in the interest of the vendors or the ecosystem to not get that stuff upstream, because it ends up being a support nightmare for them.
I'll just add one thing to that. I would say I agree with Peter. I would say you know, companies like Red Hat and the other Linux vendors have helped over years to provide guidance. They're not going to be kind of your consultants for hire to do upstreaming, but they're happy to provide guidance to vendors. I would also say that a lot of the time when you see ODMs coming along with patches, you know, some of those patches are necessary, and others are, you know, harking back to the point Leendert, I think, made around, you know, customized interrupt controllers or DMA controllers or something like this. That extends to, you know, network widgets and other devices. I mean, you know, don't try to save a buck by you know, reinventing the wheel and making some funky device. If you can just attach it through PCI or some standard interface and reuse an existing driver, your life will be a lot less painful because you will already have support in all of the major operating systems for your device. So if you are an ODM looking to, you know, get a lot of code upstream, you should be also asking yourself, why are you in that situation? And maybe that's part of the whole process as well.
Great. Yeah, I think Leendert alluded to this earlier, that we have seen compliance issues about, you know, PCIe integration in the past server SoCs and many of the SoCs in the other markets. So we have created this Presilicon Certification program with the IP providers, you know, such as Cadence and Synopsys, to identify and fix the non-compliance issues before tape out. I think Leendert already said this is going to be important, so I'm going to go around and ask the rest of you, you know, what do you think this could help, and what other recommendations you would provide to ARM and the silicon providers? I guess I will start from John.
It's interesting. I've had two different hats in this space. So I worked at Red Hat for many years, and then I went to an ARM server startup, and now I've come back to Red Hat. And so I've lived in both, telling people thou shalt implement standards this way, and then having to live them. And my whole ethos hasn't changed throughout that time. One thing I have learned in all my different lifetimes is working with third-party IP vendors. A lot of those IP vendors are still selling into embedded, non-server, non-standard markets. And so you go talk to them and they will say, well, here's a demo, it boots Linux. Note they say Linux, not any particular Linux, and it's still some kind of, you know, hacked up, modified, you know, non-standard mess that they're showcasing based on something they built a few years ago. And I went through a whole phase of depression, to be honest, when I saw this, because you know, there was a lot more that I thought they should be doing. And then I had this whole journey of discovery, talking to Doorn and talking to Arm and learning that, you know, there is a lot of work going on here to clean this up. And I have observed that in the very short term, in the past, you know, year or two, I've observed that space is really progressing much faster. And it is a direct result of, you know, some of the experiences that we all had years ago of non-compliant PCI IP in particular. But that ecosystem is learning. I mean, this is a great thing that we've put pressure on these vendors. They are actually learning. They are moving forward, not always as fast as we would like, but that's the joy of having an ecosystem with many players. On the other hand, you have many players, and over time the quality improves. So overall, I'm very happy, but you know, it's certainly a necessary effort that Arm's been doing.
Great. Peter?
Yeah, I think the Presilicon certification is critical because ultimately that is the only time to fix problems before you tape out. And, you know, ultimately a little bit of extra time there before you tape out will make a piece of silicon, a SoC that is much easily usable and hence much easier for you to sell for years going forward. So I think it's absolutely completely critical for those vendors to do that so that they know whether they've got a problem before they spend all that money to go to the fab.
Andrei?
Yeah, I think we definitely need some IP integration guidelines from ARM, you know, the do's and the don'ts, and a lot of grief could have been avoided that way. Another missing aspect when you look at ACS, you know, the dev suites, you know, perhaps it's worthwhile to invest into some kind of hardware-based testing. You know, obviously this is kind of after tape out, after you have physical silicon, just so other folks outside, you know, the vendor themselves could actually do some testing, maybe using like a low-level PCI Express debug tool like the Lambda Concept PCI Screamer or similar, you know, and outside of beyond that, all the edge stuff, of course, needs to go full standard ECAM. It's not there yet, but it has to. I mean, that's the only natural direction it can go. Why? Well, because your competitors are doing exactly just that. But as a transition, perhaps there can be an SMC-based config space access method, just so you can loop things in and get while they clean it up.
Great. Harb?
Yeah, sure. So from a silicon vendor perspective on this, I mean, obviously we're always in favor of doing as much as possible in pre-silicon, you know, shifting left as much as possible, right? But with pre-silicon, when we talk about pre-silicon validation, the test cycles are extremely expensive. Tests take longer to run. You're talking about platforms that are 100 to 1,000 times slower than what's typically what you're typically used to in silicon. And so when we create compliance tests for pre-silicon, we have to think about that and understand that and try. What we need to try to do is kind of zero in and focus on how we can have a more concise set of tests, more targeted for pre-silicon that could be more appropriate for pre-silicon platforms, so that we can hit as much as possible and cover as much as possible. You try your best, but it's never practical to run an entire test because you're talking about weeks or months to complete a compliance test if you want to run it on a pre-silicon platform. So we got to get smarter about how we change and modify the compliance tests to be more appropriate for pre-silicon platforms, so that we can get the coverage that we need and uncover those issues better prior to tape out. So that's something we hope to work with ARM on. We're in favor of this program, and yeah, we'll try to refine the details behind this pre-silicon validation and make sure that it's suitable.
Great. This is all the time that we have for this session. I'm sure there are a lot of questions in people's mind, and so you know, if you have questions, you can ask us, ask the panelists, ask me. I have the slides showing some of the the contact points for me and Berenice as well. We also have a system ready at arm.com that you can post question to. And thanks very much. I hope you enjoy the Dev Summit.